Hi guys, welcome to WissenWorld. This channel is for the people who are interested in learning new things in science and technology. To know more and to stay connected, please visit the links in the description below.
Hello and welcome to the next tutorial of Autodesk Eagle. In this tutorial we are going to make our first simple circuit of power supply with a reverse voltage protection circuit, and then we will create a PCB design. So first of all, open Eagle, click on File, New, then Project, give your project a name, then right click on the project that you just created. Now click on New, then Schematic. Now first of all, save your schematic to your desired location, and your schematic will be automatically saved with an extension of .sch. Now this is your toolbox where all the tools resides which you require while creating your design. So this is the move tool with which you can move the components. This is the mirror tool with which the components can be reversed about the y-axis. This is the copy tool, paste tool, and delete. Now this is the add part tool with which you can add components to your design. This is the bus and the net tool with which the net tool connects the components, and with bus tool you can highlight all the connections of the same category. With label tool you can label a connection, means give a name to your connection. Then with value you can give value to a component, and with name you can give your component a name. So this is the ERC tool, that is electrical tool check, to check for electrical errors in the schematic. This is the command line tool in which you can write the name of the tool that you want to use. Like here I write add, and the add part window will open. Here I can write the name of the component, and I can check or uncheck the pads or assemblies according to my requirement, whether I need a through hole component or assembly component. Now for our power supply we need these components: a power jack, diode, capacitor of 1000 microfarad, voltage regulator, resistors, LED, and some connectors. So now here I can write add or click on the add part tool. So I enter in the command line and the add part window will open. Now here we will add our first component, that is 7805 voltage regulator, but it's sorry no match. Now sometimes if this error comes, you can write the name of the component inside the wildcards, that is asterisk mark. If you write a component name inside wildcards, it will search everywhere in the Eagle library for that component and then give you the results. Now like here, if I press enter, it gave me some components. So if I choose the component of Adafruit in the drop down list, I can see different versions of 7805 regulator, and the most common that we use is this one. So just click on OK and place the component. Now press escape to return to the add component window. Now we'll add our next component, that is a diode. Now 1 and 4000 X series have the same size, whether it is 1 and 4004 or 4007. So we'll take this 1 and 4004 and click on OK. To rotate the component, you can press the right mouse button, and we'll place 4 diodes in manner of a full bridge rectifier for making the reverse voltage protection circuit. So we'll place 4 diodes here, and again press the escape key to return to the add part window. Now we'll add a 1000 microfarad capacitor, but it again shows no match, so we'll put inside the wildcards. And now we'll take the component of spark fun, that is a 5 radial capacitor. Click on OK and place the capacitor. Again press escape key. Now I'll put the LED. Now we have LED of 3 and 5 We'll use the 5 LED. Press OK and place the LED. Now press escape, and now we'll add a resistor. Now if I write register, it shows me a lot of registers. So we'll try entering the value of that register. So I need a register of 330 ohm. It shows no match, so again I'll put it inside the wildcards, and there it is. Now press OK and place the register. Now we'll put a M02. Now this M02 is for placing the connectors. Now how many connectors you need, you just need to write that number after M0. Like if you need 5 connectors, then you can write M05. If you need 8, then you can write M08. So in this manner you can place as much connectors you want in your circuit. Now we'll put a power jack for giving the DC power to a circuit through an adapter. Now this is the common power jack that we normally use. So we'll take this one and click OK. Now press escape and cancel. Now okay, so now we are done with placing all the components. Now we'll connect all these components together according to our circuit. To connect the components, you can either select the net tool from the toolbox or type net in the command line and press enter and start connecting the components together by clicking on one component and then again clicking on the other component where you want to connect it. So let's connect them quickly. Now you can zoom in and zoom out on your design by rotating the mouse wheel, and to move complete circuit you can press the mouse wheel button, keep holding the mouse wheel and move your mouse, then you can move your complete circuit like this. Now let's connect the voltage regulator. You can move a component here by selecting the move tool, and to rotate it just click the right mouse button. Let's connect the power jack also. Now here intentionally I have made these connections wrong that you can see in the yellow part, just to show you how to remove errors. So just select the delete tool first and click on the wires that you want to disconnect. Now you can select the net tool and connect the wires in correct manner. Now when you are connecting two different wires that have been previously connected, it will ask you whether you want to merge the two wires that contain the different names. So you just need to click OK, delete the remaining part of the wire also, and only the ground connection of the voltage regulator is left. So let's connect it quickly. So here we are done with our schematic, and now we'll design our PCB board. So first of all, save our schematic. Saving, we'll just click on this button that says SCHBRD to create our PCB board, and when you click on it, it will ask whether you want to create a new schematic because the .prd file doesn't exist. So you just need to click yes, and now you will be navigated to the workspace where you will be placing your components as they will be looking on your PCB and then routing them. So these are your unrouted and this is your workspace. Now this again our toolbox. Now in this almost many of the tools are same as that in the schematic, but few are different, like this whole wires, then router wires, that is to route with the copper strips that will be looking on PCB, and then the rip up tool to remove any copper wire connection that you mistakenly made it wrong. Now here you can see the yellow wires. Now these are the air wires that have not been routed. So and when a connection is not routed, it will be like this in yellow color, means it's an air wire and it's now open connection. So here is your rip up tool to delete the routed. Now one DRC is here, that is design rule set, in which you can set your different limitations that your PCB should follow. Like here are the layers, what would be the thickness of the layer, and then here is clearance, what should be the distance between two copper wires, or you can say copper tracks. Now next is pad, what is the distance between the copper pad and a hole or a SMD pad. Next is the wire, okay. And next is the distance, and here are the sizes that defines what should be the minimum size of your copper track, what should be the hole diameter, and what should be the minimum size of a wire. Now we are setting it at 25 milli-inch. If any copper connection has a track width less than 25 milli-inch, the DRC will give us error. Here are all your layers, that is top, bottom, pads, wires, and routed dimension, and many more layers. So you can also change the grid size and grid visibility by clicking here on the grid button. If you click on the display, then you will be able to see grid on your workspace. Now this is in the form of lines. You can also set the grid in form of dots by clicking the dots on the style, and your dots will be visible like this. But I usually doesn't keep the grid on while designing schematic or board design, but it is very useful when designing your components. So while designing component, grid must be on. Here you can set the size of the grid, the minimum size can be entered here, and the units could be milli-inch, millimeter, or inch. We usually go with milli-inch, so click OK. Now we'll delete the rectangle by taking the delete tool, or by entering delete in the command line and clicking on the lines, we can delete the rectangle. Now the layers can be made visible or not visible by clicking on this I button. Now here I uncheck the unrouted, so all my unrouted wires became invisible. Now while putting the components, if you're making a single side PCB, then you should be selecting the top side, and while routing the single side PCB, it should be bottom side. Now we'll take the dimension layer, and for reference we'll make a rectangle in which we'll be placing our components, and that should be the size of our PCB. So by taking the line tool, we are drawing the rectangle, and now we'll be placing the components on the top layer inside the rectangle. So just take the move tool and start placing the components inside the rectangle. You can rotate it by clicking the right mouse button. So we'll now quickly place all the components inside the rectangle area. Now to change the size of the rectangle, I'll select the dimension layer, take the move tool, and just click on the line which you want to extend, and just move your mouse. So here we have placed all the components. Now we'll be routing this by taking the route tool. Here are the properties of routing. First one is wire bend, whether you want a 90-degree bend in the wire, a 45-degree, a straight line, oval bend. Most preferred is 45-degree bend. So we'll choose the 45-degree bend. And then we have ignore obstacles, that is while routing it will ignore any obstacle and just route over it. The walk around obstacle, while routing, if there any obstacle, it will just move away from it. Now this is push obstacle, it will push the component and make it way for the routing. Now this is the size that you can set what should be the width of the copper track. We are setting as 25. Most common that we use is from 20, 25, and 30 milli-inch. So we are taking 25 milli-inch. Now we'll route it, and before routing you must select the bottom layer because it is a single side PCB and we place the components on top layer. So we need to route on the other side of the PCB, that will be the bottom layer. Now if you route on the bottom side, the track will be visible as blue in color here, and if you are routing over the top side, then it will be red in color. Like here I selected top layer, and if I start routing, it is shown as red in color. So now to remove the route, we'll take the rip up tool, click the route, and it will be deleted. Now again take the net tool, select the bottom layer, select the 45-degree wire band, and just route all the components wherever you see the open air wires. So we'll quickly connect all these components. I'm fast forwarding it so that it doesn't consume much time. And now if I set here the clearance as 6 milli-inch, that is the clearance between a track and a through hole pad. Now if I move the track closer to the pad, then you can see here are the lines and the semicircle type. So this shows that this doesn't meet the requirements according to our design rule check, and it is an error. So we'll remove it, and let's connect the other parts quickly. Now move it by using the move tool, and by clicking the right mouse button we'll rotate the, this is the capacitor. Okay, so we are done with routing. Now you can click on file and save the board design. Now either you can send it, take the Gerber file of this design, or if you are making a manual PCB, then you can print it as a PDF. Now we will check for DRC errors, and it shows only one error, that is wire stub. And if you click on the error, it will also show where is the error. So if we zoom in here, we can see that a short part of the wire is left. So we take the rip up tool and delete that, and again by taking the route tool we'll correct it. Okay, so we are done now with the routing part. Now if we check the for DRC errors, it shows no errors. You can see here bottom side there is no error, but to show an error, if I increase the size as, let's say, 30 milli-inch, and our PCB is routed with a size of 25 milli-inch. Now if I check for DRC errors, it will show the width error because according to DRC and what we have routed, the width which we have routed doesn't match. So we'll change the size here as 25 and click apply and select. Now if we check for errors, there is no error in the design. Now we'll just click on file and we'll take a PDF of it. So click on print. Now under printer select the print to a file or PDF. You can also just align it where you want to print, on the left side, on the right side, or on the center. So click OK, and this file will be saved to the location where your schematic and design file exists. So if we navigate to the location, you can see here is my PDF of the PCB design board. So that's it. Thank you.
If you like our work and want to learn more, please support us by giving us a like and do share the video. Don't forget to subscribe and press the bell icon to get a notification whenever a new video is uploaded.